Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video is going to consider matrix transpositions or how to calculate the transpose of a matrix. Okay, so let's just give a definition. Okay, so let's just say let's just provide a bit of a definition. Okay, given a matrix. Okay. Given a matrix A, okay, let's say given a matrix A of dimension m by n, okay, well then the transpose, the transpose of A, denoted by, let's say it's denoted by a t, is defined to be a matrix with dimension. Well, the original matrix had dimension mn, so the transpose gives us a matrix of dimension nm. So it is defined to be a matrix with dimension nm, okay, n by m, okay, and this matrix that results from interchanging the rows and the columns, okay, and the columns of our original matrix of the matrix A. Okay. So to calculate the transpose of a matrix, all we're saying is swap rows to columns and columns to rows, whichever way you want to do it. Yeah. Okay. So for example, okay. So for example, let's say the matrix A is equal to the matrix, let's say 1, 2, 3, 4. Okay. Well then its transpose, a transpose is going to be a new matrix. Okay. Now don't forget the dimension of matrix A is a 2 by 2 matrix. The dimension of this new matrix is going to be also a 2 by 2 matrix. We swap the rows and the columns around, which is 2 by 2 gives us 2 by 2. So this new matrix is going to be 2 by 2 matrix. And the way we get that is we change rows into columns and columns into rows. Okay, so let's have a look at the first row. Okay, in this matrix here, the first row is 1, 2. So this row now becomes the first column. Okay, so 1, 2 goes to the first column, 1, 2. Okay, let's have a look at the second row. The second row is 3, 4. So this row now has changed to be a column. So this becomes the second row, becomes the second column, which becomes 3, 4. Okay? And that's how we do the transpose. Okay? We interchange rows and columns. Okay? Let's look at another example. Okay? Let's say B is equal to the matrix 1, 7, 3, 6, 7, 2. Okay? So this matrix has 3 rows. So it's a 3 and has 2 columns, so it's a 3 by 2 matrix. So then its transpose, B transpose, is going to be a matrix that has 2 rows and 3 columns. Okay. So how do we do this? Right. So what we do is we take the first row and we convert it to be the first column. So 1, 7 becomes 1, 7, the first column. We take the second row and we convert it to be the second column. So 3, 6 becomes 3, 6. We take the third row and it becomes the third column. So 7, 2 becomes 7, 2. Okay? And that's all we do is to calculate the transpose of a matrix. You simply interchange rows and columns. Let's do another example. Okay? Let's say we have the matrix C. Let's say C is the matrix that is, let's say it's the matrix 1, 2, 3, 4. Okay, it's an unusual looking matrix this is, but how many rows has it got? It has 1 row. How many columns has it got? It has 4 columns. So this is a 1 by 4 matrix. So well then, its transpose, symbolized by C superscript T, is going to be equal to, well, a 1 by 4 matrix becomes a 4 by 1 matrix. So it's going to become a 4 by 1 matrix. Okay. So what we do is we take the first row and it becomes the first column. So this matrix is going to be 1, 2, 3, 4. Okay, there's an unusual example. Okay, where we have a row matrix becomes a column matrix. Sometimes these are called row vectors, has become a column vector. Okay, let's have a look at another example. Let's say we have D. D is equal to, let's say it's 1, 6, 7, 3, and let's say it's 3, 2, 4, minus 5. Let's say it's 6, minus 4, 7, 2. This matrix has 1, 2, it has 3 rows, and it has 4 columns, so its dimension is 3 by 4. So its transpose, okay, D superscript T, is going to be a matrix of dimension. Well, the original is a 3 by 4 matrix. The transpose is going to be a 4 by 3 matrix. So it's going to be a 4 by 3 matrix. So it's going to have 4 rows and 3 columns. So how do we do this? We take the first row and we convert it to be the first column. So the first row is 1, 6, 7, 3. That becomes the first column, 1, 6, 7, 3. The second row is 3, 2, 4, minus 5. So that's the second row, becomes the second column. So it becomes 3, 2, 4, minus 5. Okay. And finally we have the third row becomes the third column. So we have 6, minus 4, 7, 2. And we end up with a matrix that has 1, 2, 3, 4 rows and 1, 2, 3 and 3 columns. Okay. So once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope this short video that dealt with matrix transpositions was somewhat helpful. Okay, thank you for your time. Bye bye.